This video is on solving systems of equations with three variables. A system of equations can have three equations with three different variables. This type of system can have one solution, no solution, or infinitely many solutions. Since the graph of an equation with three variables is a plane, its solutions will graphically look like this. So if there is no solution to the system, then there is no point that lies in all three planes. So it could look like this, could look like this, or the planes could be parallel to each other. So there is no x, y, and z that works in all three of the equations. If there's one solution, then the planes intersect in one common point. And if there's an infinite number of solutions, that means that the three planes intersect at all of the points along a common line. Now, solving a system of three equations with three variables by graphing does not make sense. So we're actually going to do that algebraically. How are we going to do that? We're going to use elimination twice to eliminate the same variable from two different pairs of equations. So that's very important. You need to basically eliminate the same variable twice. This will give you two equations that have the same two variables. Solve this system using elimination, and this will give you the value of one of the variables, then use substitution to find the values of the other two variables. Your solution is called an ordered triple. It's an x, a y, and a z. So let's take a look at an example here. So here's my system of equations. I have 3x plus y minus z equals 1, x plus 2y plus z equals 4, and 3x minus y minus z equals 3. So I want to do elimination twice to eliminate the same variable in the equations. So I'm really liking the looks of the z's here. I notice that I have a negative 1z, a 1z, and a negative 1z here. So if I take these first two equations here, and if I add those, I'm going to eliminate z and be left with just an x and a y. So let's add those two equations. So that's going to give me 4x plus 3y, and my z's eliminate, equals 5. Now, if I add the second and the third equations, again my z's will eliminate, and I have 4x plus y equals 7. So notice I've taken the first two equations and added those to eliminate z, and then the second two equations and added those to eliminate z as well. So now I'm left with a system of equations that have just an x and a y. It's not always going to be z. It kind of depends on what your coefficients are, and you might actually have to multiply one of the equations in order to do that. But make sure that you're doing elimination twice and eliminating the same variable. Now I can actually solve this system, and this is actually kind of nice because I have 4's here. I can subtract my two equations, and that will eliminate my x's, and that's going to give me 3y minus y. It gives me 2y equals 5 minus 7 gives me a negative 2. So y is equal to negative 1, and I'm 1/3 of the way there. So I'm going to take this negative 1, and I think I'm going to plug it into this equation. So 4x minus 1 equals 7, or 4x equals 8, or x is equal to 2. That gives me my x value, and now I'll plug that x and y into either of these equations here. Maybe I'll just go with the bottom one here. So I have 3 times 2 minus negative 1 minus z equals 3. So 6 plus 1 minus z is equal to 3. So negative z is equal to, so that's going to give me a 7, subtracting 7 on each side, negative 4, or z is equal to 4. And so my final solution, my final answer is the ordered triple, 2, negative 1, 4. And that is the value of x, y, and z that works in all three of those equations. Let's take a look at another example here. You are an office supply distributor and you budget $7,200 for 80 office chairs. You can buy leather chairs for $125 each, mesh chairs for $100, and fabric chairs for $75. You want to have 3 times as many fabric chairs as leather chairs. How many of each type should you buy? So first step always is to define your variables. And instead of using x, y, z, I'm going to use L, M, and F. So let L equal the number of leather chairs, let M equal the number of mesh chairs, and let F equal the number of fabric chairs. Since I have three variables, I have to have three equations. So let's see if we can make three equations out of this. So since my variables stand for the number of each type of chair, and I know there's 80 chairs, so that means the number of leather chairs plus the number of mesh chairs plus the number of fabric chairs has to equal 80 total chairs. And then I know the cost of each type of chair, and then I know how much money I have to spend. So each leather chair is $125. So that'd be $125 times the number of leather chairs. Each mesh chair is $100, so that'd be 100M. And each fabric chair is $75. And I have $7,200 to spend. And then the last piece of information I have is that I want to have 3 times as many fabric chairs as leather chairs. So I want more fabric chairs. So that's going to be 3L equals F. Now you might think it would go the other way. Since it's 3 times as many fabric chairs, you might think 3F equals L. Well, let's think about this. Which do I want to have more of? I want to have more fabric chairs. So if I have 1 leather chair, then this equation tells me that I'll have 3 fabric chairs. If I have 2 leather chairs, then I'll have 6 fabric chairs, and that's what I want. I want more fabric chairs than I do leather chairs. Now it's just a matter of solving the system. I think I'm going to go ahead and multiply the, I think I want to multiply the first, I'm going to go ahead and multiply this equation, and you can do whatever you want by -1. Oh, I see what I'm doing here, sorry. I already have one equation that has 2 variables, L and F. That's good. So what I'd like to do is use the other 2 equations and eliminate M so that I have another equation with just an L and an F in it. So I'm going to go ahead and multiply this first equation by -100, because that's going to make it kind of easy. I can do that in my head. And then that'll eliminate my M's. So 100L minus 100M minus 100F equals -8,000. And then I'll just copy my second equation underneath there. And then let's go ahead and add those 2 equations. So my M is going to be eliminated, which is good because I already have an equation with an L and an F. That gives me 25L minus 25F is equal to -800. And since, let me give myself a little more room here. Whoops. Since I know that F is equal to 3L, I'm going to go ahead and substitute that in here. Minus 25 times F, which is 3L, equals -800. And now I have one equation with an L. So 25L minus 75L equals -800. -50L equals -800. So L is equal to 16. Substituting that back into here, so is going to give me that F is equal to 48. And then substituting both of those back into my first equation, L plus M plus F, that's going to give me that M is equal to 16. So I can buy 16 leather chairs, 16 mesh chairs, and 48 fabric chairs. So in this video we took a look at how to solve a system of equations that has 3 variables. So remember, you have to have 3 equations with 3 variables. An equation with 3 variables represents a plane, and so we took a look at the graphic for that showed what that looks like, but solving by graphing is not really feasible. So we need to solve by elimination. So we're going to do elimination twice to eliminate the same variable in two different pairs of equations. That'll give us two equations with two variables, and then we can solve using elimination and substitution as we did in the previous section.